Today we are going to begin lesson 5 of chapter 3, which is dividing integers. I think as we work through this lesson, you guys are going to find that this lesson is very, very similar and has a lot of the same characteristics as our previous lesson 4 of multiplying integers. There are no vocab words that go along with this lesson, so you do not need to fill in any vocab words for lesson 5. We're going to go ahead and begin on page 244 in your book. So please turn to the top of 244. One of the things that you're going to notice with 244 on the top, the first rule that they give you, it says the quotient of two integers with different signs is negative. Remember, quotient, okay, for those of you who may not be familiar, quotient is going to be the answer to a division problem. So, as mentioned earlier, we're going to be focusing on division. Just like multiplication, okay, when we're looking at dividing two integers with different signs, our answer is going to be negative. So this is the same rule that we worked with multiplication. Same thing applies with division. An example could be if, let's say, for example, I have negative 81 divided by 9. I'm taking a negative number divided by a positive number. Negative divided by a positive is going to give me a negative answer. 81 divided by 9 would be 9. Another simple example that I could give you would be, let's say I have positive 15 divided by negative 3. Positive number divided by a negative, they both have two different signs, so my answer is going to be a negative, and 15 divided by 3, or negative 3, is going to give us negative 5. Those would go along with a couple other examples that you can see that the book has provided for you as well. Okay? One of the things that you want to be thinking about is you cannot divide integers, or you can divide integers provided that the divisor is not 0. One thing to consider, please remember, you cannot take a number divided by 0. You can't do that. This is what we call undefined. Okay? It is not possible to take a number and divide it by 0. Okay? So please be aware of that as we work through and as we are talking about division. First example, you can see there I've got a positive divided by a negative. I've got two different signs, so therefore my answer is going to be a negative. Same thing on number 2. Negative number divided by a positive number. They're using the fraction bar for division here. Negative divided by a positive is going to be a negative as well. Okay. Number 3, they're incorporating in constant rate of change. Remember, constant rate of change is always y over x. So when I think about y over x, this would be my x column, this would be my y. As I take a look at my y's, I notice that they're decreasing by 2 or going down by 2. As I take a look at my time in hours, it's increasing by 1. So if I'm going to find the constant rate of change, I'm looking at what the change is in the y. In this case, my change in the y is negative 2 over my change in the x is 1. So my constant rate of change is going to be negative 2 over 1. Now negative 2 over 1, or negative 2 divided by 1, would be the same as negative 2, using the labels that they have, centimeters per hour. Go ahead and try Got It problems A, B, and C on your own. Pause the video as you do those. When we solve letter A, we've got 20 divided by negative 4, positive divided by a negative, so I know my answer is going to be a negative. 20 divided by 4 would be 5. Looking at letter B, negative 81 divided by 9. Negative divided by a positive is a negative. 81 divided by 9 is 9. Negative 45 divided by 9. Again, I've got a negative divided by a positive, or there's two different signs. So my answer is going to be negative. 45 divided by 9 is 5. Hopefully, as you checked your answers, you came up with those as well. As we take a look at the top of 245, we're again dividing integers. This time they have the same signs. So you're going to be looking at examples where they both may be positive or they both may be negative. The first example they have given you is an example where you have both positive numbers. Again, your answer is going to be a positive because your signs are the same. Next example, or second example, they are both negative. Anytime you have a negative divided by a negative, your answer is going to be a positive. Again, that just is reaffirming what they have up here. The quotient of two integers with your same sign is going to be positive. So please be aware of that. Both can be positive or both can be negative. Your answer is still going to be positive. Couple examples here that you can take a look at. Number 6 is a little bit different. Most of the time, these are the types of problems that end up being a little bit more trickier, or a little bit trickier, I should say. Evaluate, remember, means to solve for, so I'm taking negative 16 divided by x. They would like x to equal negative 4, so all I'm doing is I'm taking negative 4 and I'm going to plug it in for x, which means I'm looking at the problem of negative 16 divided by negative 4. Negative 16 divided by negative 4, I've got a negative divided by a negative, so my answer is a positive, and 16 divided by 4 is 4. They have 4 got it problems on the bottom of 245 that I would like you to pause the video right now and complete those. Looking at letter D, a negative divided by a negative is going to be a positive. 24 divided by 4 would end up being 6. Looking at letter E, negative divided by a negative, so I know it's going to be a positive. 9 divided by 3 is 3. Letter F, negative divided by a negative is a positive, and 28 divided by 7 would be 4. If we take a look at letter G, it says evaluate. Remember, evaluate means to solve for. A divided by B, they want A to equal negative 33 and B to equal negative 3. So what I'm going to do is I'm going to plug in negative 33 for A, and then I need to plug in negative 3 for B. So I'm going to plug in negative 33, or I'm actually thinking negative 33 divided by, and B is negative 3, so negative 3. So I've got a negative divided by a negative, which is going to give me a positive. 33 divided by 3 would be 11. So my answer for that one would be 11. Again, all they're asking you to do is solve or evaluate those expressions. Real life problem on the top of 246 that they have for us is looking at, it says 1 year the estimated Australian koala population was 1 million. After 10 years, there were about 100,000 koalas. Find the average change, keyword in there is average change, in the koala population per year. Then explain its meaning. So what they're doing is they're asking you to look at the new, okay? The new population of the koalas is going to be 100,000 minus what your original one was 1 million. And again, we know they're going down, so this should be a negative number. So I'm taking 100,000 minus 1 million, and I get negative 900,000. Divided by 10, we're dividing by 10 because there was a period of 10 years. So we're dividing those, and we end up having negative 90,000, which means, okay, when I look at explaining its meaning, it means that the koala population has changed by, or has decreased actually by 90,000 per year. Let's take a look at this practice problem. The average temperature in January for North Pole, Alaska is negative 24 degrees Celsius. Use the expression 9C plus 160 divided by 5 to find the temperature in degrees Fahrenheit. Round to the nearest degree, then explain its meaning. Okay? So remember, C is going to be our degrees Celsius. Okay, so one of the things that we're going to want to do is we're going to take 9 times negative 24 plus 160 and then divide by 5. So thinking about order of operations, please excuse my dear Aunt Sally. Parentheses, basically I'm using my parentheses for multiplication. Exponents I don't have. So what I need to do is multiply 9 times negative 24. Then what I'm going to do is I'm going to add 160. Okay, once I've figured out what 9 times negative 24 is and added 160, then we divide by 5. We use this fraction bar almost as a grouping symbol as well. You want to solve what's on top first, divided by what is on the bottom. Okay, and as you take a minute right now to calculate that or figure out what that would be, okay, we should come up with about negative 11 degrees Fahrenheit. Okay, and notice it says round to the nearest degree. So we're looking at negative 11 degrees Fahrenheit for the answer to that one. Okay. Please take a look at your got it problems. On the bottom of 246, Those are going back and reviewing your rules for dividing integers. So take a minute right now and go ahead and complete questions 1 through 7. After you've finished your guided practice problems on 246, here are your answers to double check to make sure you are correct. Number 1 should be -8. Number 2 should be -6. Number 3, you should have come up with a +6 or 6. Taking a look at number 4, when you are working on evaluating, that should be a -3. Number 5 should be 4. And number 6 should be -1. Then looking at your STEM problem, question number 7. Okay, couple parts to this. You're rounding to the nearest tenth. So our answer should have been -48.3 degrees Celsius. So therefore, when I explain the meaning, basically -55 degrees Fahrenheit is the same or is about -48.3 degrees Celsius. If you're still having trouble or need other extra help or extra problems, please feel free to check out the tutorials that are available in this lesson.